All right, let's talk about sunlight. Today, we're going to uncover the epic, ancient story behind the light we see every single day. And trust me, it's a journey that's way older and way more chaotic than you could ever imagine.
So, let me ask you something. That sunlight touching your face right now, how old do you think it is? You're probably thinking, well, a few minutes, right? That seems simple enough. But the real answer? It's just so much more surprising and way older than you'd guess.
Okay, so this is where it gets wild. You have two totally different journeys. The one we all know about is the trip from the sun's surface to Earth. That's a quick 8-minute sprint. But that's just the final lap. The first part of the journey, the trip from the sun's core to its surface, that took on average well over 10,000 years. Think about that. The light hitting you right now is older than the Great Pyramids. It's an ancient traveler.
So to really get why there's this incredible delay, we've got to rewind. I mean, all the way back to the very beginning. We're talking about the sun's birth inside this massive, swirling cosmic cloud.
You know, the sun's origin story is just fascinating. It didn't just pop into existence. All the stuff that makes up our sun, the hydrogen, the helium, all of it was actually scattered across the galaxy by the explosions of other, long-dead stars. So, yeah, our sun is literally built from recycled stardust. How cool is that?
And you can actually break down how this all happened. First, you've got this huge cloud of gas and dust just kind of drifting through space for millions of years. Then, bam, a nearby star explodes, a supernova. This sends a massive shockwave ripping through the cloud, and that's the trigger. From there, gravity just takes over, pulling the dust and gas into these dense little pockets, these star seeds. And one of those seeds, that's our future sun. It starts to collapse in on itself, getting hotter and hotter, and eventually becomes what we call a protostar. So, this protostar keeps pulling in more and more material for millions of years, and then its core hits this critical tipping point. It's right on the edge. It's about to light up and become the most powerful engine in our entire solar system. I mean, just try to wrap your head around these conditions. The temperature in the sun's core is a staggering 15 million degrees Celsius, and the pressure, it's 250 billion times the pressure we feel here on Earth at sea level. It is such an extreme environment that matter, well, it doesn't even act like normal matter anymore. And that's where we get plasma. You see, the sun isn't a ball of fire, not really. It's a giant ball of plasma, the fourth state of matter. Basically, when you pump that much energy into a gas, the electrons get completely torn away from their atoms. What you're left with is this incredibly hot, electrically charged soup. That's plasma. So what's happening inside this plasma furnace? It's nuclear fusion, and it happens in a few steps. You start with hydrogen atoms. They're getting crushed together with so much force that two of them fuse into a heavier type of hydrogen. Then that fuses with another hydrogen atom. Finally, two of those creations smash together to form helium. And this is the key part. It releases a ton of energy. This whole process is the engine that powers the sun. But where does all that energy actually come from? Well, the answer comes from probably the most famous equation in all of physics, E equals mc squared. Here's the mind-blowing part. When those hydrogen atoms fuse together to make helium, the new helium atom, it actually weighs a tiny, tiny bit less than all the hydrogen atoms that went into it. So where did that missing mass go? It wasn't destroyed. It was converted directly into a huge burst of pure energy. And when I say a huge burst, I mean it. Every single second, the sun converts 4.3 million tons of its mass into pure energy. That's like taking more than 3 million cars and just vaporizing them every single second. And it has been doing that nonstop for billions of years. So you've got this constant, incredible explosion pushing outwards from the core. And that's actually what keeps the sun from collapsing. It's this perfect balancing act. On one side, you've got the sun's immense gravity, always trying to crush it. On the other, you have the unbelievable force of fusion, always pushing out. This cosmic tug of war is what keeps our sun stable, and it's why it's been shining so reliably for all this time. Okay, so the energy is created. A particle of light, a photon, is born. And now it begins its journey. And let me tell you, it is a long, torturous, and just unbelievably chaotic trip to get to the surface. How long? Well, on average, it takes about 170,000 years. Yeah, you heard that right. And the reason is simple. The inside of the sun is one of the most crowded places in the entire universe. It's just packed. So let's follow our hero in this story, the photon. It's this tiny little packet of energy. Its one job is to escape the sun. But its path, well, it's not going to be a straight line, not even close.
This really is the best way to think about it. Imagine you're trying to walk through the most crowded shopping mall ever, but with your eyes closed. You take one step and immediately bounce off someone. You get spun around, take another step, and bounce off a wall. That's exactly what it's like for a photon. It travels a microscopic distance, slams into another particle, gets absorbed, and then shot out again in a totally random direction. It's a completely chaotic, random walk.
But here's what's so amazing. Over this incredibly long and chaotic journey, something fundamental changes. With every single collision, our photon loses just a little bit of its energy. So it starts its life deep in the core as a super high energy, totally invisible, and frankly, really dangerous X-ray. But by the time it finally stumbles its way to the surface 170,000 years later, it has lost just enough energy to become the gentle, visible light that makes life on Earth possible. And then, finally, freedom! After an absolutely epic journey that lasted for millennia, our photon breaks free from the sun's surface. And now at last, it can make that final, clear 8-minute sprint across the vacuum of space straight to us here on Earth.
So really, the next time you go outside and feel that warmth on your skin, just stop and think about what you're actually feeling. It's not just energy, it's the end of an ancient story. Every single ray of sunshine is a survivor of a battle that lasted for hundreds of thousands of years, a journey that started long before our modern world, before even civilization as we know it even existed.
So knowing this now, knowing that the light warming you isn't just 8 minutes old, but is actually an ancient traveler that literally fought its way out of the heart of its own star, how will you see the sun tomorrow? A simple sunny day? Well, it might just never feel the same again.